Taking some more examples from the miscellaneous exercise. See the 12th one. They are saying find the sets A, B and C such that A intersection B, B intersection C and C intersection A are non-empty. So you frame three sets A, B and C, but ensure none of these pairwise intersections should be empty set. But they have to be framed in such a way that when we take intersection of these three, it comes out to be a null set. So let us assume, say A is a set with the elements 1, 2, 3, and let me assume B is 3, 4, 5, then C can be taken as 1, then 5 and 6. Okay, so let us see whether the given conditions are fulfilled or not. If not, then we need to make changes in them. What is A intersection B? When we take intersection of these two, we get a common element which is 3. In the same way, when we take intersection of B and C, again there is a common element which is 5. And taking intersection of C and A, it is 1 which is common among all the three. Now checking for the next condition, which is A intersection B intersection C. You can write intersection of any two first and then take its intersection with the third one. Now A intersection B, we found it was having only one element, that was 3, and then its intersection with the set C, which has numbers 1, 5 and 6. So when we take intersection of these two, we get a null set. So we could frame three sets according to the given condition. You can have some set on your own also. Now moving on to the 10th one. They are saying, suppose we are aware A intersection B and A intersection C are equal sets, then from there we cannot come to the conclusion that B and C will be equal. That means if these two intersections are equal, that doesn't mean B and C will also be equal. Even this you can justify through some example. So define set A, B and C in such a way that intersection of AB and intersection of A and C comes out to be same. Let us check. A is say again 1, 2 and 3 suppose, and B is say 3, 4, 5. C we have to frame very carefully because it says A intersection B and A intersection C has to be same. So I am defining it as 3, 6, 7 or simply 3 also you can take. Okay, now look at this. What is A intersection B? A intersection B is a singleton set with 3 and A intersection C is also a singleton set with 3. So what do we see? We find A intersection B is equal to A intersection C. But look at the second part. Do we see that B and C are equal to each other? Are we coming to that conclusion? If you compare B and C, they are not equal set. There only one element is exactly the same, remaining two are different. So if we know that a intersection of A with B or intersection of A with C is equal, then that doesn't mean B and C will also become equal. They may or may not be equal. Generally, they will not be equal. Then see another one, fifth. It says show that A is a subset. This is a proper subset of B. So if I draw a diagram and this is set B, then A will be a set, proper subset of B. So you can see it is completely contained in set B. So keep this diagram in mind and then try to attend to this. So we have to show that if A is a subset of B, then this set C minus B will be a proper subset of C minus A. How do we show one set is proper subset of other? If I know every element of the first set is also an element of the second set, then it becomes its proper subset. Here we already know A is a proper subset of B. It is given. We have to show C minus B is a proper subset of C minus A. So I will show every element of C minus B is also an element of C minus A. So we'll start from here. Let me take X denoting all the elements of C minus B. So every element of this set is denoted by small x. Now keeping the definition of difference of two sets in mind, we can write this means X belongs to C and X does not belongs to B. Okay, same step can be rewritten as, first part I'll keep same, second I will change. Now look at this diagram. If X is not in B, where it will be? It will be outside B. Not in B means not in this region, outside anywhere. So if X is not in B, obviously it will not be in A. So I can interpret this part as X does not belongs to A. Reason you can write, since A is a proper subset of B. So whatever is missing from B will also be missing from A. Now look at this again. This means where is X? X is in the set C minus A. So we found every element of C minus B is also an element of C minus A. Therefore, we can say C minus B is a proper subset of C minus A.